This is Superhuman Artificial Intelligence. So my name's Memo Akten. Thanks for coming. I hear there's a big horse race on today, so I really appreciate it. And thank you for inviting me. It's really great to be in this incredible building and incredible exhibitions. The title of my talk is Fundamental Frequencies, and I'm mostly going to talk about some of my recent work in the last couple of years, which is around particularly deep learning. Before I go into that, though, I'd like to give a very super quick overview of a selection of work going back about 15 years to kind of give an idea of where I come from and how I got into doing what it is I'm doing. And that is, basically, I've been interested in computation. Computation as a language of transformation, as a language for designing behavior. And this is what I've been doing since I was about 10. And I gradually became more and more interested in computation, not just as a language, but as a way of augmenting ourselves, as a way of, interested in how it augments us, how it augments our mind, how it augments our physical abilities, and ultimately how it affects society and culture. And in this day and age, when we're constantly talking about algorithms and algorithmic governance and everything, it's become increasingly more topical. So going back to the title, I'm sure a lot of you know what a fundamental frequency is. I just want to tie it into the theme of this talk, because it'll be the, pardon the pun, the fundamental frequency. I don't know if any of you can tell what this is. I'm guessing you can. If anyone can, I'll be quite blown away. But if I were to show you what this is, again, if anyone can tell me what this is, I will be super impressed. I'm guessing a lot of you know what this is once you hear it. So on the top we have the time series signal. On the bottom we have the same signal transformed into the frequency domain. And what you're hearing is a note of a piano with maybe you can hear a bit of background noise. So already in our ear, the cochlea is doing a transformation that's analogous to this, where the little hairs vibrate, respond to different frequencies, and then loads of signals get sent to the auditory cortex right here. And then the ratios of all the dominant frequencies are analyzed, and from the ratios of their frequencies and amplitudes, you're able to infer that this is a piano producing a single note, not a violin, it's not a dog. Furthermore, you hear a single note, which is the fundamental frequency. In this case, if any of you have perfect pitch, this is a concert A, or standard pitch A. And this is what I'm really, really interested in. How is it that we're able to take data that looks kind of like noise at first glance, but it has a very particular structure, a very particular distribution, and then what we receive in our conscious awareness is incredibly simple, but very, very concise, very high-level meta-information, i.e. a piano playing a note. And this is also why I'm interested in machine learning, because machine learning is effectively the field of extracting meaningful information from data. And deep learning in particular is the field of extracting meaningful information from very high-dimensional big data. So this is the underlying theme of my talk today, with a few other themes. And I'd like to combine that with this other realization that I had a few years ago, that all of my work is either about waves or God. More broadly speaking, about the intersections between science and spirituality, or the collisions between nature, science, technology, ethics, ritual, tradition, and religion. And looking back, I think when I used the term waves, I think what I meant was patterns in nature which we humans have managed within our limited cognitive abilities to collectively recognize, decipher, and formalize into equations and theories, often that we somehow even find elegant or beautiful. And when I use the term God, I think I mean those mysterious aspects of nature that we have yet to understand, and the lengths that we will go to, the stories that we will invent to try and make sense of. And I think when I use the term quantum mechanics, I was referring to the fringes of human knowledge, which we empirically somehow know to be true, yet we can't really understand on a human level. So this is one kind of waves, oceanic waves. I grew up by the sea in Turkey, so I am obsessed. I could spend all day. That in itself I find fascinating. Why am I so obsessed with this? But there are, of course, many other types of waves. This is a series of work that I started in 2011. Again, it has many, many motivations. One of the motivations is looking at the emergence of complex patterns from very, very simple rules. In this case, the interaction of very simple oscillatory behavior. But the reason I'm showing it is not just that. So emergence is a very, very common theme. A lot of us work with it. These complex patterns emerge from very simple rules. So here, this is one of the simplest things I've ever made. There's one insanely simple rule that governs this system, and all this complex behavior emerges. But what I find really fascinating is, as you watch this, you're probably seeing lots of moving parts. Maybe it appears to be quite complicated. But the more you look at it, you will start to identify rules in this system. You will simplify it. But chances are that the patterns that you start seeing are not the patterns that I put into it. So not only do we have complexity emerging from simplicity, which is the basis of pretty much the entire universe and evolution, but then you are resimplifying that. You are extracting structure. You were looking for fundamental frequencies. So I explored this series in many different forms, video and sound installations, quite immersive, projection-based. I'll skip that actually. I did quite a large version with 80 robotic spotlights in a palace. That was quite crazy. I'd like to just show a tiny excerpt of this. This is what you see when you're in the middle, looking straight up, seeing these patterns projected onto the cloud, which is where God lives. And I'll come to that. I did a live performance with 16 drummers, which was actually commissioned by Future Everything. Thanks, Drew, wherever you are, in his previous life there. So this work is at the opposite end of the spectrum. This is from 2009. It's at the opposite end of the spectrum because the previous work is governed by incredibly simple, one incredibly simple rule. You look at it and it appears quite complicated. Whereas this is the other way around. First, let me ask, can anybody tell what this is? Some of you may, some of you may not. But if I press play, then maybe you will start recognizing what this is. So this in itself I find quite fascinating. We recognize through movement. That abstract blob is actually a humanoid figure. And now that it's moving, you can recognize the humanoid figure. Now, for example, it's quite clear, but even as it becomes more abstract, we predict the future. We run forward models in our mind. So you latch onto the limbs. Even though when it's an abstract blob, you know where the head is, you know where the legs are, you know where the head is. And then once it becomes clear again, you compare your predictions to what you're observing. And if it matches, great. If it doesn't, you correct your hypothesis, hopefully. But the reason why this is opposite to the previous project is, from my point of view as the developer of this, it was very complicated. There's loads of rules here. This is a camera tracking a dancer being fed into like an old school computer vision system using optical flow, which is advecting a fluid simulation. Loads of calculus. But you look at this, you don't see any of that. You just see a person dancing. That's the fundamental frequency of this signal. And this is something that AI has, for example, yet to achieve with this level of complexity. So these are the kind of things that I'm interested in. How do we, humans versus machines, able to parse incredibly complex scenery and extract meaningful signals? This was a work I made in 2014, so I haven't even got into AI yet. This, I think, is the last project in this series of thing. It's a touchscreen installation I made in 2014. It was initially inspired by ecosystems and the very fragile, delicate balance that they hang in. So this might look like a static image, but it's actually about 10 million entities that are oscillating furiously. So on a microscopic scale, it's very dynamic, but on a macroscopic scale, it's in equilibrium. It's in homeostasis. But once you touch the screen, you upset this balance, and the system falls apart. It starts oscillating on a macroscopic scale. Now, it turns out, most of the time, it will find a new point of equilibrium. Even, I guess, similar to when a meteor comes and strikes the planet and wipes out 75% of all species, somehow the planet finds, after a few 100 million years, it finds a new equilibrium. So this is a property of a lot of non-linear dynamical systems, not just populations, but we see this in biology all the time. We see it in our stock market, in finance, in lots of political trends, other biological systems. It's also thought to be a major principle in how the brain operates, in the sense that the brain is a very non-linear dynamical system. We have millions of synapses, millions of neurons with thousands of synapses each, creating these waves and ripples of firings. Yet somehow, most of the time, the brain manages to not go out of control. Of course, sometimes it does, unfortunately, and this is when we have seizures. But most of the time, it manages to stabilize itself. And it's even thought, some neuroscientists claim, that the act of cognition itself, the act of learning or perception, is the attempt of the brain to try and normalize its activations in response to external signals, whether from outside or from within the body. So I'm sure you're all very familiar with this aesthetic. In July 2015, Google dropped upon us this thing called Deep Dream, which changed a lot. It's when tech companies realized that releasing code was a really, really good way of viral marketing. And now we see it all the time. So when Deep Dream came out, I was really, really blown away. And I wrote a blog post about this because it encapsulated a lot of things that I was thinking about at the time. So I made this pretty much, the day that they released the code. And I love Deep Dream. Not the aesthetic, but the poetry of what's actually happening. Not to go too deep into it, but so this is a neural network that's been trained to recognize objects in scenes. And what Deep Dream does is, the algorithm is, you give it an image, and you select a couple of neurons, and you modify the image to amplify those activations. This is a bit like, metaphorically speaking, you look at a cloud, and then you draw what you think you see. And then you look at what you drew, and then you draw again what you think you see. So there's this feedback loop, a confirmation bias feedback loop. That's interesting. But what I find really interesting is everyone looking at these images and saying, oh, I see puppy slugs. Oh, it's just bird lizards. But of course, there are no bird lizards. There are no puppy slugs. We are literally doing what Deep Dream is doing. We are recognizing distributions, and we are striving to make sense of what this random with a particular distribution, and we are completing the loop that Deep Dream started. So where Deep Dream thought it saw bird lizard-like features, it amplified those, and when we look back at this, we can't help but complete that picture. Because ultimately, this is what goes into a neural network. And the neural network has been trained, and it literally takes it on a journey through multiple dimensions and transformations in space and time. That's what a deep neural network is. And out comes this. And then we look at this, and we project meaning onto it, because that's what we do. That's what we've always done. We look for structure around us, and then we invent stories based on who we are and what we know. Even these words that I'm saying right now, I don't know what they mean to you. I know what they mean to me, but you're projecting your own meanings onto these very sentences based on everything you've read, everything you've seen. This is from a series called Learning to See. There's many motivations, again, behind this particular work. So I am doing a PhD. My PhD, I'm not really talking about today. My PhD is very practical in that my PhD is about how can humans exert meaningful human control over generative deep neural networks in a real-time and performative manner. So on one hand, this is related to my PhD, but it's also linked to this theme that I was talking about just now, in that here's a neural network that's been trained on tens of thousands of images that I scraped from Flickr in this case, and now it's looking upon the world, trying to make sense of what it's seeing, but it can only see the world through the lens of what it's seen before. It can only see what it already knows, just like us. This is a presentation of this work. It's currently at the Barbican, which opened a few days ago as an interactive installation. So there's a table covered with similar kind of junk that I used in my video. So some dirty rags, some cables. And you can come and you can play, and then you can see on the projection the machine's vision of it. And you can come and you can spend just 2 seconds playing with this stuff, or I find myself actually spending very long just trying to arrange the perfect bouquet, or to shape the perfect ocean scene, or build the perfect flame. So the models that I used, as you can tell maybe, they're the 4 elements, where flowers represents earth, water, fire, clouds represent wind or air. And the 5th element, beyond our planet, the void, the ether, the cosmos, God. It's actually trained on images from the Hubble Space Telescope. And the interesting thing about this particular model, trained on the Hubble Space Telescope, is we might be inclined to think that this particular network has learned what outer space looks like. But of course, this isn't entirely accurate, because this is not what space looks like. Hubble doesn't give us accurate photos of what space is. Hubble just streams data. And then we have teams of engineers, scientists, artists, humans, who take that data, stitch them together, colorize them, composite them, and produce romanticized visions of what we think space should look like. So actually, this network is not learning what space looks like. It's learning what we think space should look like. So already we've injected our own bias into this network. And of course, there's another angle to why I like this particular model, because I like reminding myself, in particular, that the atoms in my body, the atoms in all of your bodies, were forged in the hearts of supernova billions of light years away, billions of years ago.
This is a world of wonders.
So another reason why I'm really interested in AI is, well, the explosion of AI in the last couple of years, particularly in context of after about a decade of big data, and that this is no coincidence that after a decade of big data, we have an explosion of AI. And there's a few perspectives as to why I find this really fascinating. One is, I like the metaphor relating the emergence of AI as a means of coping with big data, analogous to the Darwinian evolution of intelligence. as a means of dealing with big data in biology, especially around 500 million years ago when vision evolved and all of a sudden simple organisms had to deal with this very high-dimensional sensory input to evade predators, to catch prey, and as some believe, create the pressure to start the Cambrian explosion. And some organisms might even have become developed to start making models of the environment that they live in so they can make more accurate predictions. And going even further, some organisms, to be able to form any kind of social interaction, will need to start interacting with each other, not as millions of organic cells clumped together or vibrations in a quantum field, but as entities with goals and desires and feelings. So in a way, your consciousness is an interface through which I can try to empathize with you. But of course, that's not the real reason why we have AI right now. The people who are funding AI, who are the greatest advocates, their business models rely on making sense of big data. They have more data than they know what to do with, so they need these algorithms to basically summarize everything that they've been collecting and produce executive summaries. This is why, effectively, a lot of the developments that we have today are surveillance technologies. And it's safe to say if World War I gave us analog computers, and World War II gave us digital computers, and the Cold War gave us internet, it's the mass surveillance of the war on terror and the internet business models that's giving us deep learning and AI. But there's another angle that I really like, which actually Drew also showed a slide similar to this, with a nice transition from the pioneering nurse and statistician, Florence Nightingale. She said, "To understand God's thoughts, we must study statistics, for these are the measure of his purpose." I'm fascinated by the evolution of the thousands of deities and overseers that we've had, and how they've always co-evolved with the host societies, based on whether it's modes of subsistence or how wrathful these overseers are, and how these correlate with the characteristics between the deities and the belief systems and the social structures of their societies that they have formed in. And I think there's a fascinating parallel between the current rise of AI and mass surveillance and the ultimate panopticon that is religion, the all-seeing eye of God. It was ancient religions that imposed omnipotent powers watching over us, judging us, protecting us. Those were myths fabricated to control the masses. And now, as we're losing our spiritual sensibilities and drowning ourselves in materialism and technological submission, our overseer too is adapting and co-evolving. We don't fear the old gods anymore. They cannot protect or control us, so we need new ones. We killed God, as Nietzsche says, but we are rebuilding him with technology to match our techno-culture. And he lives up in the cloud of all places, watching over us, listening to our thoughts and dreams in ones and zeros. We are creating a digital God for our digital culture. But it doesn't even end there. This new overseer in the cloud not only watches us to protect the good and punish the bad and deliver very precise ads, but now as it learns and becomes more intelligent, it makes decisions for us too. We had started offloading our memory to devices, to stone tablets, to bones, to walls, tens of thousands of years ago. But it used to be we had a physical connection to these devices. But now, we don't use these things to just store. We use them as portals. We use them as tablets of communication with our overseer in the cloud. We query the cloud, the intelligence in the cloud, with this new channel, this new language of scripture, which some of you might recognize as JSON. But it doesn't even end there. It used to be the churches of the old gods used to also be the bastions of morality and right and wrong, but also the purveyors of art and culture. They used to be the ones who inspired, who made us, encouraged us to tell stories and create history. They were also the commissioners and the funders. And now we have our tech companies moving into that space too. So in 2014, I wrote a poem, a collaboration with Google. Not people working at Google, but actual Google, the search engine. Because Google is the keeper of our collective consciousness. We confide in it. When we have a problem that we can't tell our friends, we ask Google. So it knows everything we know, it feels everything we feel. And so this is more a collection of prayers. As you can see, I type in a few words, Google autocompletes, and this is the collective consciousness of 2014. And I've done this every year. It's quite fascinating to see how these trends have changed. In the 2016 version, punching Nazis was in there. Anyway, I'm not going to read it, I'll just move on because time's quite short. But sticking to language models, ironically, this is a project that I did actually commissioned by Google when I was artist in resident there in 2016 in the Artisan Machine Intelligence program. So there were these word models where you can take this system and give it a huge corpus of text. And this knows nothing about language, and it goes through and it learns meanings of words, and it learns how to associate these meanings. So they're called word embedding models, such that it positions these words in a high-dimensional space, such that you can do mathematical operations on them. For example, it learns about gender. Queen minus king plus man, it gives you woman. So what this means is that the vector from the word man to woman is kind of similar to the vector from king to queen. It learns about tenses. It learns about country capitals. So this is a model that Google made, trained on 100 billion words of news. So it learns everything in that news in terms of the kind of biases and prejudices that we might have. So I was curious, what else has the model learned? So I wrote a few Twitter bots. The first bot I wrote, it picks completely random words, does completely random mathematical operations on them, and it tweets the results. And I was rather blown away to see that Twitter plus bot is a meme. So I thought, okay, this is a winner. So again, the interesting thing for me here is not so much, or not only what has the model learned, but how do we interpret these results? Like when I look at, for example, human minus love is animal, what does this mean? Has the model learned something? I mean, I could write an essay on this, but is that me or is that the model? I actually did write an essay on this, so I'm going to skip because you can read the essay. But I also did one about gender, inspired by this quite famous result, that a man is more likely to be a doctor, while a woman is more likely to be a nurse. So I wrote another Twitter bot that basically explores this space, finds words, looks at the correlations. I'm going to move on though. So I'll quickly talk about this project if I can. This is a VR piece. It's not about AI, but it gets to the heart of a lot of these things that I've really been interested in. I say it's VR, but it uses VR technology, but it's about as far from VR as I think one could imagine. It used to be thought that seeing happens that we shoot rays from our eyes, and these fiery rays coalesce with the material that's out there, and that's how we get the sensation of seeing. Even people as smart as Plato thought this is how seeing happened, and they call this the extramission theory of vision. Of course, they were wrong. That's not how seeing happens. Light falls on the retina. But what I do like about this theory is it really underlines the idea that seeing is an active process. Seeing just doesn't happen to us like a camera. We have to look. We were talking earlier about how we saccade, etc. Because a part of the eye that's actually high resolution is the fovea, and the way we construct this scenery is through saccades. We integrate. This is the key thing. As our eyes saccade, they move around the space. The brain integrates the action signals that it sends with the signals that are coming back. And we know a lot of this from dating back to the 50s and 60s. Alfred Yarbus did these amazing experiments. One key thing is he would ask people a question, like, how old are these people? What are they talking about? How affluent are they? And this affected the way that people scan the scene. So the actions that we take affect the meaning that we extract from our observations. So the final thing I want to talk about is binocular rivalry. It's a phenomenon that's been known for hundreds of years. It's when the two eyes are presented images that are radically different or monocularly dissimilar, as it's known. The brain is unable to integrate them into a single cohesive 3D percept. So what you get is you get a bistable state. So given these two static images, your conscious visual, the image in your conscious mind will be something like the image on the right, but it will be animated. Furthermore, it will be unique to everybody. It's impossible for me to see what you see in your mind when you are presented with these things. Of course, this is how everything is all the time. And so to me, again, the metaphor here is, I don't know what meaning you're taking from the words I'm saying. I don't know what meaning you're taking from this presentation. And sometimes we forget that. Sometimes while we're trying to communicate, we forget that experience is very, very subjective. So this is a VR piece. It's an installation that looks a bit like this. This is at Ars Electronica. The piece was commissioned by Stripe. The imagery is very abstract. I'm hoping to release it quite soon. There's kind of no point showing it because I'm also out of time, I think. I've got 2 minutes. Great. Okay. So another thing I'll mention then, which is quite interesting. So right now, there's no rivalry. So the image appears to be physically outside of you when you experience it. You feel like the same way you all feel external to me. But as rivalry kicks in, the image physically feels like it's located inside your head, which is where seeing actually happens anyway. So that was a happy accident. So I'll quickly try and squeeze in one last project. What does love look like? What does faith look like? Or ritual or worship? What does God look like? These are very abstract, subjective concepts that don't have very clearly defined visual representations. So how could we teach a machine to understand these concepts? Definitely not how I chose to do it in this piece, which is I scraped Flickr for about 100,000 images that were tagged with love, life, art, nature, ritual, worship, God, etc. I also scraped YouTube for anything I could think of that had any kind of spiritual ritual, ranged from Gregorian chants, the Islamic call to prayer, ayahuasca ceremonies, and trained another neural network on the sound. So the sound you're hearing is also generated by that. So this is a neural network that's trained on what our collective consciousness thinks that these very subjective concepts look and sound like. There's another angle, which is, again, as part of my PhD, I'm very interested in how we can control these systems. So we can train these generative neural networks, they can generate images. But I want to know, how can I, as an artist, control this? I don't want a random walk in this latent space. I want to construct a film. So this is actually a 1-hour film. It's very abstract. It's called Deep Meditations. This is how it usually looks like. This is currently on in Brazil at Itaú Cultural. This is at Kenninji Temple in Kyoto, which I still don't know how I ended up doing this. But I managed to show it there at a Zen Buddhist temple. That was very fascinating. And this is it showing currently in London as part of Cernar Plus D at Hotel Me by Melia. So this is a 10-story high atrium. And yeah, I guess I'll just jump to the end. Thanks for listening. I don't know if I've got time for questions, but yeah, cheers.